Hello students, welcome back. I am S.K. Nigam, PhD Chemistry, Kendriya Vidyalaya. Now in this lecture, in this session, I will teach you about the fourth colligative property, which is osmotic pressure. Okay, so this is the fourth colligative property, osmosis and osmotic pressure. So before going in detail, I will just show you one more activity. So just look at activity and after that we will discuss it.
I have taken 2 glasses of water and I have also taken 2 grapes. Now I am going to show some kind of activity, or you can say some kind of changes which is going to be happen here. Now in 1 glass of water I am going to mix some salt to make it solution. Okay, so just I am going to add the salt into the water to make it solution, whereas other glass is having the plain water. Okay, so I'm dissolving it only by shaking. Approximately it get dissolved. So there are two kind of glass. One is having the plain water and another is having the salt solution. Okay, so it is pure water, pure solvent. It is a kind of solution which is having salt in water, and I am just dropping these 2 grapes which are having approximately same size, one in the solution and one in the plain water. Okay, so let's see what is happening after some time. Let's see what happened after some hour. So this glasses of salt water, means you can say it is a solution, and this glasses of plain water means it is a pure solvent. Let's see what happened. So this is the grape and this is the grape of the salt water. So just see the size of this grape. It gets swell up, whereas this grape just shrink. You may observe the surfaces, it get a little puffy, a little soft, because it lost the content of water present in the grapes. Okay, so it is very clear. The grape which is dipped in the solution of salt, it loses water, and the grape which is filled in plain water, it gain water. So why does it happen? Because salt water is having greater concentration, so it is a kind of hypertonic solution, and because of this hypertonic solution, the osmotic pressure of the solution is high, and this is the reason the water content of the grape will just move out, and this movement of the water content of the grape will be continued till the concentration in both the side, means inside the grape and outside the grape become same. Okay, so this is the example of exosmosis and this is the example of endosmosis. Okay, clear?
So I think most of the concept you all have understood about the osmosis and osmotic pressure. So let's begin. What is osmosis? So it is a very simple concept which we have learned in the previous classes. Actually, osmosis is the movement of the solvent molecules from the lower concentration to the higher concentration, and there are various examples around us. For example, if you just put some reagents into the water, then after some time you will observe these reagents will swell up. So actually it is the example of osmosis in which the water molecules are moving inside the resin. Okay, like that there are various examples. For example, whenever our just in our home, when the pickles are going to be prepared, first of all our mother, what she do, she actually just cut into the pieces all these parts of the mango, and after that just place some salt, or in some cases there the there is a layer of the sugar also, and just keep it aside for some hour, or you can say for a whole day. Why this kind of phenomena is happening? Because with the help of salt or the sugar, the water content of these parts of these slices of the mango will come out, and the chances of the growth of the microbes will be very lesser. So these are certain examples which generally happen around us, around the whole day. These are the examples of the osmosis, or whenever you are just doing many work of the water, and you are continuously doing the work of water till 2 hours or 3 hours, and after that you will observe that your skin of these finger will be just turned into different shape, or you can say they become a little soft. There is some kind of swelling like this. So these are certain examples which are happening around us throughout the day, and these are the examples of the osmosis of actually. And it is just similar to the diffusion. Actually there is a difference between the osmosis and diffusion. Diffusion is the movement of the particle from higher concentration to the lower concentration, whereas osmosis is the movement of the solvent particles from lower concentration to the higher concentration. Okay, so there are various examples. They are also discussed here. For example, raw mango shrivel when pickled in brine solution, wilted flower revive when placed in fresh water. So there are various places where in the vase of the water, the wilted flower are dipped, and after some time you will observe the wilted flower will be just revived. Blood cells collapse when suspended in saline water, etc. If we look into these processes, we find one thing common in all, that is all the substances are bound by membrane. Okay, and these membranes are either animal origin or the vegetable origin. For example, pig's bladder or parchment, or can be synthetic. It is such as cellophane. So these are the membranes which are having small pores. They are very small in size, and they only allow to just pass through it solvent molecules, and they will not allow the movement of the solute particles, because solid particles are generally bigger in size in comparison to the solvent molecules. And if this happens, then what will happen? They just stop the solute particles to pass through this membrane. So those membranes are termed as semi-permeable membranes, which allow only to pass solvent through it, and they do not allow solute to pass through it. Okay, so these kind of membranes are termed as semi-permeable membrane. So this is generally present in our cell also. Along with this semi-permeable membrane, they are selectively permeable membrane, which allow certain particles to pass through it, and rest of the particles. And all these properties only depending on the size of the pores and the size of the solute particles. Okay, so now next one is, here is an example. With the help of this diagram you will understand. For example, if this is a container, and it is connected with the another container, these two are the container, and these two containers are filled with and here you place semi-permeable membrane, and just here you fill solvent molecules, and here you fill solution. So it is solution and it is solvent. So, and this is the semi-permeable membrane. So what this semi-permeable membrane do? It allow solvent molecules to move around, and it does not allow to move the solvent molecules from this container to this container. Okay, so what happens? And if you are not placing any object over this, okay, over the top surface or top layer of the solvent as well as solution, then what happen? Because in this container there is the less amount of the solvent in comparison to this container, because it is having the pure solvent and it is having the solution in which solute plus solvent both are here. Okay, so what happened? Until and unless the amount of the solvent in both the chamber will not be same, the solvent molecule move from the solvent container to the solution container. So what happened? When the solvent molecules are moving from solvent container to the solution container, the level of the solution will increase, and the level of the solvent chamber will be decreased. For example, it will reach here, and in the case of solution it will reach here. So these two are the positions of the solvent and solution, and this is because of the process which is happening around the semi-permeable membrane, which is termed as osmosis. Okay, so this is the process in which solvent molecules are moving from lower concentration to the higher concentration. Okay, so this is the osmosis, and this will happen continuously until and unless the amount of solvent will not be same in both the container. Okay, so this is all about the osmosis. Okay, now what is osmotic pressure? Osmotic pressure is the amount of pressure basically which is required to stop the process of osmosis, and which can be explained with the help of this diagram. So the same diagram is here, which I have made here. The difference is we have placed a piston over the container of the solution as well as over the container of the solvent, and in both the container P atmosphere will be the pressure which is applied equally. Okay, but if only plain pistons are placed here, then what happen, again the same process will happen. This piston will move upward because the solvent molecule is moving from this container to this container, and then it will move till the amount of solvent will not be same in both the container. Okay, so if you want to stop the process of osmosis, if you don't want to increase the level of this solution in this container, and you don't want to decrease the level of this piston in the container of solvent, then you have to apply some amount of the pressure. So this amount of pressure which is needed, this is the pi, it is written by the pi, this is the amount of pressure which is needed to stop the process of osmosis, because when this process of osmosis will stop, then only it is possible, the level will not rise. Okay, so this is the amount of pressure which is required to stop the process of osmosis, and this is termed as the osmotic pressure, which is written here. So this pressure that just stops the flow of solvent is called the osmotic pressure of the solution. So I think the osmotic pressure is clear to you. Osmotic pressure is the amount of pressure which is required to stop the process of osmosis. Okay, and this osmotic pressure is completely depending on the concentration of the solution. If the concentration of solution is very high, it means the osmotic pressure will be high, because the solvent molecules will move very rapidly to this container to just maintain the amount of solvent in both the containers same. Okay, so basically it is completely depending on the concentration of the solution. If the concentration of solution is high, the osmosis will be very faster and the osmotic pressure will be very high. Okay, now come to the mathematical portion of this colligative property. So osmotic pressure is generally, because again it is depending on the amount of the solute filled in this container, it means it is also depending on the amount of the solute. It means the concentration of the solution is the basically concept here. So osmotic pressure is proportional to the molarity, that is C, of the solution at given temperature. So what happens if it is directly proportional to the molarity, means pi is the osmotic pressure. Actually it is directly proportional to the concentration of the solution at given temperature, because this is the this is happening at the it can be happen at the room temperature also. So when you remove this proportionality sign, then this R and this capital T term will be placed, or you can place this T before the removing the proportionality sign. So basically this is the formula: pi is equal to CRT. Pi is the osmotic pressure, C is the concentration of solution, R is the gas constant, and T is the absolute temperature. Why it is absolute? Because you have to take it in Kelvin. Okay, so this is the concentration, and this concentration of the solution is molarity. It is molarity, it is not molality, it is molarity. Okay, so what is molarity? So molarity is equal to number of moles of solute upon volume of solution in liter, and if it is in ml, then what is next one is multiplication by 1000. So this is pi, and after placing this n2 by v on this formula, the pi is equal to n2 by v RT, where n2 is the number of moles of solute, and this n2 can be calculated with the help of given mass upon molar mass. So n2 is the number of moles of solute, which is equal to given mass of solute upon molar mass of solute. And just arranging all these values, pi is equal to W2 upon M2 into V RT, and just by sending this V to the left hand side, this equation will be there, pi V is equal to W2RT by M2, and this can be compared with the PV is equal to nRT. This can be compared with this equation, pi V is equal to N2RT. It may be just compared with this equation. This is the ideal gas equation. And again, in this equation, you can say the molar mass of solute is at the denominator place. Means again, the colligative property is inversely proportional to the molar mass. Okay. Now with the help of all this formula, pi V is equal to W2RT by M2. M2 is equal to W2RT by pi into V. So all the variables you can just know very well. M2 is the molar mass of the solute, W2 is the given mass of the solute, pi is the osmotic pressure, V is the solution volume of the solution in liter, R is the gas constant, T is the absolute temperature. Okay, so by knowing all these values, you can calculate either of the variable present here. Now, with the help of osmotic pressure, you can also calculate the molar mass of the solute. Now, so basically, what kind of colligative property you have just gone through? There are 4 colligative properties. The first one is relative lowering of vapor pressure, then elevation of boiling point, then the depression of freezing point, and the fourth one is the osmotic pressure. And in all the 4 colligative property, you can calculate the molar mass of the solute. But out of all these, we will prefer the osmotic pressure method, okay, for calculation of the molar mass of the solute. So osmotic pressure method has the advantage over other methods as pressure measured is around the room temperature and the molarity of the solution is used instead of molality. So there are 2 basic reasons why this process is used for the calculation of the molar mass of the solute, and this is also the 1-mark question of the board examination. So why osmotic pressure is preferred? Because it is it can be happen at the room temperature, and in this kind of the method, you are just taking the molarity of the solution in consideration, while in other cases you are taking the molality of the solution under consideration. Okay, so why this temperature term is here? Because in the case of relative lowering of vapor pressure or depression in freezing point or elevation of boiling point, you have to increase or decrease the temperature. Means it cannot be happen at the room temperature, but this process can be happen at the room temperature. Okay, so next one is isotonic, hypotonic and hypertonic solution. So there are 3 kind of solutions, and these solutions can also be said that these are the solutions which are having the same osmotic pressure, and hypotonic solutions are those solutions which are having low osmotic pressure. Hypertonic solutions are the solutions which are having the higher osmotic pressure. Isotonic, actually they are based on the concentration term. Iso means same, and tonicity is the concept which is taking generally for the concentration. So if there are two containers which are having the same concentration, then they are termed as isotonic solutions. And if for example there are 2 containers again, and they are separated by the this semi-permeable membrane, and if both the solutions are having the same concentration, means there will be no any kind of flow of solvent from either this container to this one or this container to this one. It means these solutions are having same concentration, so they are termed as isotonic solutions because they are having the same osmotic pressure. But if the concentration of these 2 containers are different, for example they have higher concentration, this container have the higher concentration and this is having the lower concentration, then what happens? The solid molecules will move from lower concentration chamber to the higher concentration chamber. It means the osmotic pressure of this container is lesser than the osmotic pressure of this container in which the concentration is higher. So the container which is having lower concentration solution, they are hypotonic solutions, and the containers in which higher concentration solutions are just kept, these solutions are termed as hypertonic solution. Okay, so all the concepts are here, and this can be just understood with this discussion here. So all of there are various discussion, and one more concept is here, the saline solution, which generally just introduced when anyone is hospitalized, and that saline solution is having 0.9% sodium chloride solution by mass, because our blood is having the same composition. And if anybody which is having 0.9% of the NaCl solution in the blood, it is introduced the solution which is having greater concentration with the 0.9% of the NaCl solution, then what happened? The exoosmosis happen. Exoosmosis means because the solution which is introduced into the body is having higher concentration, so, but the blood cells are having 0.9% concentration. It means the blood cells become hypotonic, and the solution which is present around the blood cell is higher, means they are the hypertonic solution. So in that case, the blood cells just release their water content and blood cells shrink. Okay, and if reverse happen, if anybody is injected with the solution which is having lesser concentration than 0.9% saline, then what happen? This solution become hypotonic, which is introduced into your body, into the body of the patient, and the blood cell which is having 0.9% become hypertonic. Then what happen? The water content of the content around the cell, blood cell, will be absorbed by the blood cell, and blood cells swell up. And when they swell up, one time will arise when these blood cell will burst, and ultimately it may lead to the death of any patient. So generally, whenever any saline solution is injected to the body of any patient, it is very clear 0.9% NaCl solution will be the normal saline solution. Okay, now the example 2.11, 200 ml of ml. Why it is ml? Because cubic centimeter is the unit which is equal to 1 ml of an aqueous solution of a protein contain 1.26 gram of the protein. The osmotic pressure of such a solution at 300 Kelvin is found to be 2.57 into 10 power minus 3 bar. Calculate the molar mass of the protein. So all the values are given here, only you have to put it in the formula of M2 and you can calculate the value. One thing you have to remember, that whenever you are keeping all the values on the formula, you must see the units will be same. Okay, for example, here the value of R is taken as 0.083 liter bar per Kelvin per mole, because the volume is in liter and pressure is in bar. So you have to keep in mind that all the units will be same, and after the calculation you have to put the just unit here, otherwise 0.5 marks will be deducted in your copy correction. So this is the concept of the osmosis and osmotic pressure. One more, here there are various examples are mentioned. For example, a raw mango is placed in the concentrated salt solution for which there is a loss of water and the pickle shrivels, or you can say shrinks, while flower revive when placed in fresh water. A carrot that has become limp because of water loss into the atmosphere can be placed into the water, making it firm once again. All these processes are happening in our home also. We are continuously just going through these processes throughout the day. Water will move into them through osmosis. When placed in water containing less than 0.9% salt, blood cells swell up due to flow of water in them by osmosis. And this point is very much important. People taking a lot of salt or salty food experience water retention in the tissue cell and intercellular spaces because of osmosis. The resulting puffiness or swelling is called edema. So the person who are taking excessive salt or excessive sugar, in those cases the concentration become higher and the cell loses its water content, and because of it the amount of intercellular water content will be increases, and because of that increase in the intercellular water, there is a puffiness which is termed as edema. Along with this, water movement from soil to the plant roots and subsequently up to the upper part of the plant is partly due to osmosis, which is termed as transpiration, which you have already learned in lower classes. Transpiration is the phenomena in which the water is just transported from root to the topmost of the, or you can say all the part of the plant. It is only because of osmosis. Okay, so the preservation of meat by salting and of fruit by adding sugar protect against bacterial action. First of all, if you are placing the salt or sugar over the meat or over the fruit, so there are two concepts. The first one is the water content will be lost by those food items or meat or fruits, and along with this, if these are applied on the fruit or the meat, the microbes which are already present on over those meat or fruits, they lost their water content and they die. So this is also the concept behind. So the process of osmosis, a bacterium on salted meat or candied fruit loses water and shrivel and dies. Okay, the next one is reverse osmosis and water purification, which is generally termed as RO. So basically, reverse osmosis, when you apply pressure greater than the osmotic pressure, then what happens? The water start moving from salt solution to the fresh water chamber, because there are two concepts earlier we have discussed. If you have not placed any piston or you have not applied any kind of osmotic pressure, then the water movement from solvent container to the solution container till the amount of solvent will be same in both the container. Okay, and after that we have studied, if you apply the pi, which is the osmotic pressure, the osmosis will stop, and in the reverse osmosis, the osmosis get reverse, means it generally osmosis happens from the solvent to the solution side, and in the reverse osmosis happen from the solution to the solvent side, and it will happen only when you applied greater the pressure which is greater than the osmotic pressure. So in the reverse osmosis, the osmosis get reverse, and it is only happen when you applied the pressure which is greater than the osmotic pressure. Okay, and this reverse osmosis phenomena was generally done in for the desalination of the seawater, and this is generally happen in those countries. It was generally happen in those countries where there is the very scarcity of the potable water. But nowadays it is become very common. uh, it has become very common because everyone is just installing the RO plant in their home. So this is all about the reverse osmosis. It is also very clear cut concept. There is no such kind of difficult thing. I think you can go through the topic and understood all the things. So reverse osmosis is generally the process in which the pressure which is greater than the osmotic pressure is applied to reverse the process of osmosis. Means the movement of solvent molecules from higher concentration to the lower concentration, which is just reverse to the osmosis. Okay, so this is all about the osmosis, osmotic pressure, reverse osmosis. I hope you like this video. If you like the video, please like, share, and you can also comment on it and subscribe also.